Hello, dear students. Professor Dheeray Rana welcomes you to his class. I'm here to discuss with you today oxidation number. Let us start. Try to understand how oxidation number is assigned for a element or ion. Oxidation number. Students, there are certain rules to assign oxidation number. Rules to assign oxidation number. Okay. Let us start. We try to understand them one by one. Number one is the oxidation number of an element in its free state. Free state is a state in which the element exists in nature. For example, it is like N2 for nitrogen, O2 for oxygen, O3 for ozone, S8 for sulfur, P4 for phosphorus, like that, etc. Is always 0. Okay? Oxidation number of an element in its free state is always taken as 0. Students, rule number 2 is that oxidation number of hydrogen is generally what? It is generally +1, as you have seen in case of HCl. When it dissociates, it forms H positive and Cl negative. So H positive +1 is the oxidation number of hydrogen. But in some metal hydrides, suppose this HCl dissociates, then it becomes H positive plus Cl negative. So H positive, it is +1. Okay. So oxidation number here is +1. But if you see, in case of certain metal hydrides, what happens? Suppose, for example, we have CaH2. Calcium is what, students? Calcium is 2 positive, then H2 is negative here. Okay, 2 atoms of hydrogen, one is having 1 negative charge. So 2 atoms, 2 negative charge, and then 2 positive, so calcium hydride. So here the hydrogen, in metal hydrides, the oxidation number of hydrogen is -1. This is very important to note. Okay. Now, third point. We will discuss third point. So third point is oxidation number of oxygen is generally, everybody know, oxidation number of oxygen is generally, it is -2. Everybody know. Okay. So in general terms, O2 negative, we write down, that is 2 negative. But in case of hydrogen peroxide, in case of H2O2, remember, then its oxidation number is -1. Then oxidation number of oxygen is -1. This is very important to note, and you can also infer it from here. H positive, H2 means 2 positive, and O2 means O negative and O negative. It is not 2 negative, it is only negative. So it is very important. And in case of BaO2, barium dioxide, here it is oxidation number of oxygen is -1/2. This is very important, and you should note it, right, students? Because it's very important. Next thing, fourth point that you should keep in mind is the oxidation number of monoatomic ion is same as that of its charge. Okay, oxidation number of monoatomic means one atom ion is same as that of its charge. For example, we have Na positive or K positive. So in case of Na positive, we have what? Oxidation number of sodium is +1 here. And another example is Mg2 positive. Here oxidation number of magnesium is +2. Right, students? And if we take an example of Al3 positive, then here also oxidation number of aluminium is +3. So this is what is here for you. These are certain rules. So next, rule number 5 is the oxidation number of alkali metals. Alkali metals you people very well know. This is lithium, sodium, potassium, etc. Okay, first group element is always +1. Remember this. But oxidation number of alkaline earth metals, that you know very well, second group, these are like you know very well, beryllium, magnesium, calcium, etc. is always +2. I think it is easy to remember. Okay, students, the rule number 6 is the oxidation number of halogens. The oxidation number of halogens, that you know group 17 elements are these. So like chlorine, fluorine, bromine, iodine, etc. is generally it is -1. Note it. Okay, the oxidation number of halogens is generally -1. Okay. Now, there is an exception. You know, in all the compounds, fluorine has generally -1 oxidation state. But in case of HOF, remember, in case of HOF, it means the oxidation number of fluorine is +1. Remember this, it is +1. Okay, students, I think this information is useful. 7th rule is the algebraic sum of all the, remember, the algebraic sum of all the oxidation numbers of all the atoms in a neutral molecule is always 0. This is very important to note how it is 0. Suppose this salt is neutral to us. It is here plus, it is here minus. It plus and minus will be cancelled out when they are added. So it is neutral molecule and algebraic sum of all the oxidation number is 0. In the same manner, if we have H2SO4, H2 is what? Negative, negative, a positive, positive, and SO4 sulfate is 2 negative. 2 negative, but hydrogen are 2, so 2 positive. They will cancel out. It is also neutral. So this is very good example of assigning the oxidation number for salts. Next is uh, the sum of oxidation number of all the atoms in an ion is equal to the charge on the ion. If we take the example of complex ion, complex compounds, you have seen, you have studied. So in complex ions, you should note that the sum of oxidation numbers of all the atoms in the ion is equal to charge on the ion. So it is very important to note. And if we talk about, next point is, if we talk about polyatomic ions, in case of polyatomic ions, you can write down the algebraic sum of all the oxidation numbers of all the atoms, all the oxidation numbers of all the atoms in the ion is equal to the charge on the ion. In the ions is equal to the charge on the ions. So in complex ions and in case of polyatomic ions, the case is similar. Right, students? Now, these are certain rules which you have to follow while assigning the oxidation number for a salt or for a compound. So now we will try to understand these rules with certain examples. So dear students, now we will try to understand how to calculate oxidation number. So write down calculation of oxidation number. So dear students, let us take an example of calculation of oxidation of sulfur in H2S. Okay, so what would you do? You would do, let oxidation number of sulfur is X. So you will write down H2S, hydrogen plus 1 is its charge, and these are two atoms, so twice plus X is equal to 0. It is plus 2, okay, plus X equals to 0. So in case of X is what? X is here is minus 2. So in this case, in case of H2S, oxidation number of sulfur is -2. This is the method to solve. Now find out oxidation number of chromium in Cr in K2Cr2O7, that is your potassium dichromate. This is your another example. So how we will proceed in this case is write down K2Cr2O7. K is what? Potassium, that is +1, and 2 atoms of potassium are there plus. Let Cr's atomic number is X. So it is twice of X and O7. And you know oxygen is what? 2 negative. So 7 into 2 negative equals to 0. So what will happen here is it is 2 plus 2x minus 14 equals to 0. And it is what? Minus 14 and plus 2 means minus 12. So 2x minus 12 equals to 0. And x is equal to 12 upon 2, that is plus 6. So oxidation number of chromium in K2Cr2O7 is +6. This is the method through which, oxidation number of chromium in K2Cr2O7 is +6. We have written all the oxidation states and X for chromium, and we have then adopted the proper procedure to find the value of X, that is +6, and so we can write oxidation number of chromium in potassium dichromate is +6. So this is very best method. And suppose if we have a simple question, find oxidation number of sulfur in SO4 2 negative. Now there is note down 2 negative is here. So how we will write? Let oxidation number of sulfur is X, then we will write X plus 4 times oxygen, that is 4 into -2 is its charge, equals to the exponent 2 negative. You will write it here, right? And it will become -2, right, students? So X plus 4 to the 8 plus minus minus. So -8 equals to -2. X -8 equals to -2. Then what happens? Here it will be solved in mathematical terms. X equals to +8 minus 2, that is -6. So X equals to -6 means oxidation number of sulfur in SO4 2 negative is -6, right? So I think now the concept of oxidation number is clear to you. So myself, Professor Dheeraj Rana, is ready with next video also. So we will try to understand the next concept. I think this concept of oxidation number is clear to you in a very efficient and very well manner. Thank you.